Hello friends, my name is S1S Lengal and I would like to say a few words about a trip I took with Vojta and Bára in implementing a decision procedure for the logic S1S. What is S1S? S1S is a second order logic interpreted over the set of natural numbers with one function symbol S, which is interpreted as the successor. So for example, the successor of 0 is the number 2. The logic allows quantification over both individual and set variables, so it is quite powerful. S1S was one of the first logics for which automata-based decision procedure was implemented. This was done by Bichy in 1962, pretty much by inventing Bichy automata. It is equivalent to omega regular languages, so it has the full power of Bichy automata. The complexity is very hard. The logic itself is non-elementary, that is a lower bound. Intuitively, if you have a formula, for every quantifier alternation in the formula, you can get an exponential explosion in the state space that you need to search. What can it be used for? You can use it for specifying correct or incorrect behaviors of a system and then use it, for example, for model checking. Why not use LTL? S1S is more expressive. In LTL, you cannot describe all omega regular properties, and it can also be more concise than LTL, and that is non-elementarily more concise than LTL. Apart from this, you can also use it for reasoning about natural numbers, and you can also use it to encode other logics because it is quite general. You can encode in it, for example, weak S1S, Pressburger arithmetic, first order theory of omega automatic structures, or some more obscure logic such as the first order theory of Sturmiar words over Pressburger arithmetic. In this paper, we implemented the classical procedure of Bichy, which works by translating a formula into a Bichy automaton and then testing satisfiability by testing language emptiness of the formula. In this, we implemented and evaluated several algorithms for handling Bichy automata, and we compared this approach with the approach of using loop deterministic finite automata for deciding S1S implemented in this paper. A few words about how S1S is decided. This is done by translating a formula into a Bichy automaton. You start with atomic predicates of the formula, and atomic predicates are 2, x is a subset of y, and y is a successor of x. You get a Bichy automaton for each of these formulae, and then for larger formulae, for every Boolean connective, you perform some operation on the automata. So, for example, for negation, you perform complementation of the automaton. For conjunction, you perform intersection of automata. For disjunction, you perform union of automata. And for existential quantification, you do some projection over the alphabet of the automaton. We implemented the procedure in the tool called Alice, which is in Python. The input of the tool is a simple Lisp-like format, so the formula here can be written in our format like this, so it is very easy to write and parse. The algorithms for intersection, union, projection, and emptiness checking are the standard algorithms for handling Bichy automata. For complementation, we experimented with 2 algorithms, Chevez rank-based algorithm without any optimizations, and determinization-based algorithm implemented in Spot. We also use simulation to reduce the size of the intermediate automata. And here are the results of our experiments. We compared the sizes of the obtained automata with the sizes of the loop DFAs from the paper here. You can see that in this column we have our procedure with complementation done by Chevez algorithm. The second column is complementation done by Spot. You can see that in this case the complementation of Spot usually gives us better results. For example, in the last row we get 21 to 11. What you can also observe is that our algorithm, the standard Bichy automata-based decision procedure, yields Bichy automata with significantly less states than the loop DFA-based procedure. For example, for formulae 19 and 20 in these 2 lines, which belong to some parametric family of formulae, the sizes of the Bichy automata, it grows exponentially, but the sizes of the DFAs, they grow even faster. That's all from me. Thank you very much for your attention.